Good morning. Welcome back to all my subscribers and viewers. So today I'm going to post another video. So today we are going to see about another algorithm called as a selection sort algorithm. So in this Wikipedia, I have already posted a first sorting algorithm called as a bubble sort. Thanks for your all your views. So we have reached 100 number of views for the particular video. So I'm going to post a second video. It's on a sorting algorithm called as a selection sort. Now we will directly go to a selection sort algorithm. First, we will start with how it works. Selection sort algorithm. So it's a type of a sorting algorithm. Next, simplest algorithm. So I'm going to explain about the working concept of it. Let me consider about three things are there. There are three persons out there who has to be arranged in an ascending order. That is like shorter person to the taller person. I'm going to arrange it. Now, how the selection sort works? It's like it will first take one first element, then this first person will be compared with the remaining list of persons. Among those people who was the smallest one, that people will be identified and they will be made to stand in the first element, first position. Right? This is how the selection sort works. Selection sorts always focus on two things. One is like unsorted part of an array, and other one is your current element. So your current element will be compared with the remaining unsorted list of elements. Let's say that the first person, if I'm going to say that I equal to 0, then from I equal to 1 to the end of the list will be considered as an unsorted array. Now we will take the first element, first person, and in that unsorted element the first element in it. So we will try to make a compare. For comparison, we will be making a swapping concept. When will we be swapping it? When your left hand element is greater than your right hand element, that element you are trying to compare it, then we will make a swapping of it. So this selection sort algorithm, I'm going to explain the concept for arranging in ascending order. So we will take these two peoples, compare it. The first person, is it greater than the second person? Yes, it is true. If that is true, then what we will do, like we will be swapping those two persons, right? Once it has been done, so we have to check with the remaining list of elements also, remaining list of unsorted elements also, right? Now what we do, like we will jump to the next person in the unsorted list. So what we do, like we will try to compare between these two peoples. That is like first element we have took that position element and the next available unsorted element. Again we will try to compare it. When we will try to compare it, so we are going to check it whether the person at the left hand side is greater than the taller than the person at the right hand side. No, it is not true. So we don't want to swap it, which means that this we called as the first iteration. After this first iteration, we have found out the first smallest person and we have moved that first person to the first locations. Now this we call it as the unsorted array. So now we are going to do it for this unsorted array. Again we are going to compare it. So the person at the left hand side, is it taller than the person at the right hand side? Yes, it is true. So what we do, we will be again swapping back these two peoples. Now you can look at that after two passes we have two different people standing in the ascending order from shorter to the taller person. Got it? Now this will be repeated for the several iteration until all your data is getting sorted. Now this is now the concept has been over. So we are going to see about theoretical part, technical things, how to write about selection sort algorithm. What are the things to remember about selection sort algorithm? First thing, selection sort is a comparison based algorithm. So we will be comparing two positions or two peoples or two data at a time. It sorts an array by repeatedly selecting the smallest or largest element from the unsorted portion, which means that's how selection sort works. Always we try to find the first smallest person, move that first smallest person towards the left end, and then we will find the second smallest person, move that second smallest person to the second left end of your array. Like that it goes on. It sorts an array by repeatedly selecting the smallest if it is in ascending order, or largest if it is in the descending order, if you want to arrange your data in the descending order, element from the unsorted portion and swapping it with the first unsorted element. This process continues until the entire array is sorted. Example, let's say that we are going to take an element at ith position, then we will be comparing with from I plus 1 position to the end of your array. So in that I plus 1 position to the end of your array, you will try to find the smallest element, and then you will try to check with your current ith position. So if it is true, then you will move that smallest position to that particular ith position. This will happen for several iteration until your entire array gets sorted. So selection sort, like bubble sort, it also takes very much time, heavier time. So it is the slowest algorithm. The runtime will be like order of n square. So bubble sort and selection sort will have the same runtime, that we call it as an order of n square. Now the key idea behind it, consider that this is a sample input 3, 5, 4, 2, 7. You want to sort this data in an ascending order. Now again, as per the logic, I will tell you. First we will take the first element. If you are storing this array element in an array, then the first position will be your 0th position and the last position will be your 4. So your 5 element will be storing from the position 0th position to n minus 1 position, where here n equal to number of elements. Here we have number of elements as 5. So n minus 1 position is the last position, that is like 5 minus 1, which is 4. Now we will take the first element, assume that first position element, that is like 0th position element, as the smallest element. Now we will be trying to compare with the remaining list of unsorted element, which was the smallest element. So whichever element is the smallest, that will be pushing to the 0th index of your array. Now we will be trying with comparing 3 and 5. Is it 3 greater than 5? No, false. So no need for swapping, or you can say it like, since still 3 is the smallest element. Again we will try to check with 3 less than 5. Is it true? Yes, true. So we will go for it. Now next we will try to go over 3 and 4. So we will try to compare it. 3 less than 4. Again, since still 3 was the smallest element, so there is no change in the minimum element. And then again we will be trying to check with 2 and 3. So we will be checking with which is the smallest element. So but here 3 is greater than 2. So the smallest element was 2. So what we are going to do it, we are going to mark 2 as the minimum. So we are going to change your minimum value as 2. Change your minimum value as 2. Now you can see that here I have changed my minimum value. I have updated my minimum value. You can see it, right? So every time you are trying to find that particular element, whether it is the minimum or the element that you are trying to compare on the right hand side, unsorted array is the minimum element. Which are the minimum, that you will get updated at. Okay. Now next thing you are going to have it comparing with 7. So 7 and 2 you try to compare it. So in that 7 is the greatest element, so 2 is still the smallest element. So what we do it like, we will be leaving as it is. Now we have found out which was the minimum element, 2. So 2 was the minimum element. So what we have to do, we have to put that 2 element to the 0th position element. Now after end of it, you can see that we have this smallest element among the entire array. First smallest element in the entire array, we have it, that was available in the left hand side, 0th position of your array, first position of your array. This is iterations 1. This is iteration 1. Once iteration is 1 is over, we have one sorted element available at your left hand side of your array, left hand side of your first 0th position of your array. Got it? Now we will proceed with the next set of element. Now again we will be going for the next unsorted element. In that unsorted element, we are going to take this as an element and we are going to assume it that as the minimum element. Now we are going to comparing it with the remaining list of elements, right? So let me do it. So first 5, 5, grade 5 and 4 we will check it, which is the minimum. That value should be updated it. Here, but comparing between 5 and 4, which is the minimum, 4 is the minimum. So it will be updated at the minimum value as 4. Now again, after that, we will be going to the next item. So next item was 3. So we will be comparing with 4 and 3. Again, in the 4 and 3, which is the minimum? Yes, 3 is the minimum. So we will be updating your minimum value as 3. Got it? So we are changing our minimum value. Now again, once it's done, so we will be going to the next element. So we will be comparing between 7 and 3. Between 7 and 3, which was the smallest element? Still 3 was the smallest element, so no need to change your minimum. Now we have reached the end of your array. So in the remaining unsorted array, the next smallest element we have found it as 3. So what we have to do? We have to swap that third element. We have to swap the third element to the first position of it. Now after this is called as a second pass. So after end of the two passes, we have achieved with two smallest elements that were moved to the left end of your algorithm, left end of your array. Right. Now again we will be trying to take the next possible element, next unsorted list of element. In that 4, I'm going to take it, that is like second position. I'm going to assume that in that second position there is some element is there. We didn't know whether it is the smallest element or largest element, so we are going to assume that is going to be the minimum. Now we are going to find it out which is the minimum element in that. So 4 and 5 we are going to compare it. So which was the minimum element? Still 4 was a minimum, so no need for swapping. Again we will be going for it. We will be checking for it. So again 7 and 4 we are going to check it out. Which is the minimum element here? 4 and 7. 4 is always the smallest element. That is your minimum assumption was right. So you will no need to swap it. Now we have reached the end of it, which means that which are element that was stored here as the minimum element, that should come here in the second position element. So already 4 was that the correct position, so no need for doing anything else. Now 3 iterations are over. After end of these 3 iterations, we have 3 smallest element that were arranged in the left hand side of your array, sorted in an ascending order. Got it? Now we will be proceeding with the remaining unsorted list of elements. The remaining unsorted list of elements are this thing. So we are going to check it out. So again we are going to have it third position element. Assume it, that is the minimum element. We are going to assume it. Then we are going to comparing with the remaining list of elements. So here again we will try to check it 5 and 7. 5 was the still minimum element, so it remains same as it is, no need for swapping. Now finally we have only one element, so no need to compare it. So the last element, that is the minimum element, that is already in that position, so no need to compare it. Your algorithm works fine. So now we have, after end of some number of iterations, you have all the elements that was arranged in the proper ascending order. Similarly, you can implement this thing in a vice versa for descending order. Instead of swapping by comparing, finding the minimum value, you have to find the maximum value in the remaining unsorted element. That is the concept for sorting, implementing a selection sort algorithm for ascending order. Similarly, if you want to implement for a descending order, just change your condition. Instead of finding a minimum value, you have to find the maximum value in the unsorted array. That's right. Now we will try to